highly reactive pale blue gas with penetrating odor. So there's a kind of smell and odor, and it is an allotrope of oxygen made up of three atoms of oxygen. Audible, right? Okay. So it is something which is formed when molecule of stable form of oxygen, which is O3, is split by ultraviolet radiation or electrical discharge. And ozone is naturally occurring gas found in very small traces in the Earth's atmosphere. And so basically, you will see that in the atmosphere of the Earth, atmosphere aspect we had discussed earlier. So in that atmosphere, it's a certain kind of natural gas which is in the atmosphere in small traces. So ozone is formed by the action of sunlight on oxygen. So this is what is the okay. So this is what it is in terms of the this is how the ozone is consisting of. And if you see uh, from the sunlight point of view, it is something which is formed by the action of the sunlight on the oxygen. So if you see the ozone layer, we live in a troposphere, is something which we discussed earlier, troposphere, where most of the weather occurs, and something like rain, snow, and clouds. Okay, so about troposphere is the one request is people don't put your video mode. Okay, if you want to put your display pic and all that is visible is okay, because it will become overload. Don't switch on your video mode. The video mode, keep it switched off. Mr. Kiran Kumar, please switch off your video mode. So,
Someone else's audio should be muted.
everyone, please put your audio on mute and video on switch off. Please, everyone. So, above the troposphere is the stratosphere, which we discussed earlier, and this is an important region in which the effects such as ozone form.
Audio not clear, sir. Audio not clear.
So that is the ozone will be forming a layer. So ozone layer is a protective thin band in the stratosphere above troposphere that shields the Earth from the harmful ultraviolet rays coming from the sun. So the rays that come from the sun, which is which is actually harmful, the ultraviolet rays. Okay, this ozone layer is like a protective, protection from that layer of ultraviolet rays. So ozone is formed in the atmosphere when ultraviolet radiation from the sun strikes the stratosphere, splitting the oxygen molecules O3 into atomic oxygen O. So this is something which you need to keep in mind with respect to ozone. So the in the atmosphere, ozone is formed when the ultraviolet radiation from the sun strikes the stratosphere, splitting the oxygen molecules O3 into atomic oxygen, which is O. Okay, and the atomic oxygen quickly combines with further oxygen molecules to form ozone. Okay, this ozone dynamics dissipate the UV, which is ultraviolet rays, as heat. So, which is why you see when this lockdown was there all over the world, the the ozone layer was much more in a protective way because lack of vehicular movement. So there is an equilibrium between generation and distinction of ozone, which leads to a steady state of concentration of ozone layer in the stratosphere between 20 and 26 kilometers above the sea level. So if this stratosphere ozone layer is condensed vertically to standard temperature and pressure, its thickness averages about 0.29 centimeter above the equator and may exceed 0.40 centimeter above the poles at the end of winter season. So the thickness of ozone layer is not uniform because of this. Okay, and at the same time, the concentration of O3 in the stratosphere changes with season, and it is the highest during the spring season, which is between months of February and April, and it is lowest during the rainfall season during the months of July to October. So the absorption of UV radiation by ozone layer increases exponentially with its thickness. Therefore, maximum amount of UV radiations are absorbed in the tropics, that is near the equator, and this is about because of this amounts to decrease towards the poles. The layer of ozone formed in the stratosphere is also known as Chapman layer. Okay, so the stratosphere contains about 90% of all the ozone in the atmosphere. Some ozone is also formed in the lower atmosphere, which is troposphere. The pressure of ozone can be a good or a bad thing depending on where it is present. In the atmosphere, ozone acts as ozone shield and protects the Earth's organisms from harmful effects of strong ultraviolet radiation. So basically, this ozone aspect is which is present in the stratosphere. It will act like a shield and it will protect the various living organisms which are on the planet Earth. These living organisms on planet Earth will be protected by the ozone, and the ozone shield will be formed so that the harmful effects of the ultraviolet radiations are not there or minimized. Is it reasonably audible? Is it? Are you able to hear me properly?
Yes, you're audible.
Yes, sir. Yes, sir. It's audible.
So a trace of if you see
It's audible, audible.
a trace of ozone in troposphere can damage the human lungs and tissues, and also harm the plants. So so ozone should not be present in the troposphere, and ozone in troposphere is also a greenhouse gas and contributes to the greenhouse effect. Okay, so the total amount of ozone in a column of air from Earth's surface up to an altitude of 50 centimeter is the total column ozone. The total column ozone is recorded in Dobson units. They call in short form DU. It is Dobson units. So, a measure, this Dobson units is a measure of the thickness of the ozone layer by an equivalent layer of pure ozone gas at normal temperature and pressure at sea level. So, in other words, 100 DU is equal to 1 mm of pure ozone gas at normal temperature and pressure at sea level. So, the average amount of ozone at mid latitude is 3 mm or 300 DU. Okay, because 100 DU is equal to 1 mm. Okay, and 3 mm or 300 DU is what is there at the mid latitude level as a average amount of ozone. So the mean total ozone amount in the atmosphere varies geographically and seasonally. It is slightly less than 260 DU at equatorial latitudes. It increases towards the poles in both hemispheres, going up to a maximum of about 400 DU. So the level of ozone in the atmosphere is naturally fluctuating by small amounts during all the time. It is affected by the seasons, changing wind patterns, and other natural factors. For billions of years, delicate balance or we can say equilibrium has been maintained by the nature. However, today many human activities are harming the ozone layer and are leading to a decrease in the ozone levels in the upper atmosphere. One sec. Uh, Coming to the ozone hole, the ozone hole refers to the thinning of stratospheric ozone layer during the first year during the springtime. So in 1985, British Antarctic Survey team reported that there was reduction in the ozone level. So there has been a lot of data with respect to this, and in 1957, since 1957, they've been collecting the data properly, and actually, the in 1985, the British Antarctic Survey team reported obvious reduction in ozone levels over their survey station at Halley Bay, based on the data science since 1957. So the ozone hole is formed each year when there is a sharp decline, currently up to 60% in the total ozone over most of Antarctica for a period of about 2 months during southern hemisphere spring, which is during the months of September and October. So it has been found that during every southern spring since then, 50 to 95% of stratospheric ozone is destroyed at a height of 15 to 24 kilometer above Antarctica, creating pockets which have been described as the Antarctica ozone hole. So they've come to describe this one as Antarctica ozone hole. So the hole is observed every spring. So once in a year, during the time of spring, they observe this ozone hole. However, ozone-rich air from the tropics gradually fills up these holes. The phenomena of the hole is thus a temporary one. So the latest scientific research has proved that ozone hole occurs over the Arctic as well. So the if you see the Arctic stratosphere, this is less vulnerable to chlorine attack because it is the warmer and fewer clouds are formed in that place. Also, it is not isolated by the vortex as it is in the case of Antarctica. So coming to the depletion aspect of the ozone layer. So ozone depletion is a chemical that destroys the ozone in the stratosphere. Most ozone depleters are chemically stable compounds containing chlorine or bromine, which remain unchanged for long enough to drift up to the upper atmosphere. Man-made emissions of CECs occur mainly in the northern hemisphere, with about 90% released in Europe, Russia, Japan, and North America. So the gases such as CFCs, we'll see what is CFCs. CFCs are insoluble in water and relatively unreactive, are mixed throughout the lower atmosphere and rise from the lower atmosphere into the stratosphere. The winds then move this air poleward. The CFCs damage the uh, ozone layer. So if you see the ozone depletion substances, the first one is CFC, chlorofluorocarbons. Okay.
Sir, recently NASA any declared the ozone mist.
Just a sec. తీసుకుంటారా? ఓకే.
ఎందుకంటే నేను ఎక్కడ పోవాలి మళ్ళీ ఇలా అదే ఇంట్లోనండి.
So we'll pause the session for today. We'll
Sir,
continue
recently NASA scientists have reported, sir, any reported? NASA.
NASA?
Any reported, sir, ozone depletion?
No, the recent reports which are worth talking about is the fact that ozone layer uh, positive impacts were there because of the lockdown and all, because of lack of vehicular activity. Okay, and that was the main report from various observation institutions. So the CFCs, if you see chlorofluorocarbons, they are the one of the most ozone depleting substance. Okay, I'll type it here so that
Any recently climate finance developed by developed nations.
okay, Srinivas sir has come because of the lack of because of the technical issues we were not able to do earlier. So now we'll pause for today. We'll continue tomorrow. Srinivas
Thank
sir
you,
will
sir.
take. phone లో తీసుకుంటారా ఇక్కడ
Thank you, sir.
Thank you, sir.
Okay, okay.
Thank you, sir. Thank you, sir.
So we will be receiving another link for another class,
No, no,
right?
No, no, sir, we'll continue. I'm here.
Okay, sir.
Can you hear me?
Hello?
Yes, sir.
Okay. Okay, just to wait for few minutes. Let me just make my
Okay, sir.
things ready and then continue.